Welcome everyone. Welcome everyone on a Friday morning to this exciting event. Thank you all for the interest and registration, and also thank you to all the participants today. As you'll see, we have a chock-block agenda. We have tons of speakers who will be talking about applying the Cloud-Edge-IoT Continuum in energy contexts, opportunities for you to participate in these areas, and also chances to find funding in the different ways. So to start, so if we go to the next slide, my name is Brendan Rowan. I come from a project called Unlock CEI. We're part of two initiatives that are supporting the coordination of this EU Cloud-Edge-IoT ecosystem that I'll explain a bit later today. So why are we here? Next slide. Really, we want to bring you all together to talk about what it is that the EU Cloud-Edge-IoT Continuum is doing for the energy transition and the challenges that we have to meet in the future of Europeans' energy, so of Europe's energy systems. And we want to showcase with some excellent use cases here who will talk through exactly how they're applying MetaOS infrastructure and edge-based computing in energy contexts and describing how they're doing it, and a chance for you to meet with them. We want you to come and connect with how the edge can actually contribute towards these areas and the role that it is playing in driving forward what we need for our stable and resilient energy systems. Also, the chance for you all to become part of the EU Cloud-Edge-IoT ecosystem. This is a really great ecosystem full of many, many top actors across industry and research, and there's opportunities for funding through initiatives called the Open Calls for all of you who wish to be part of it. And finally, the chance for you to all meet each other and network within the breakout rooms in the second part of the session that will be able to allow you to meet other tech providers and also partners for developing your own applications within this field. So to go quickly to the next slide. Just a reminder for those who are unfamiliar what we're talking about when we talk about the Cloud-Edge-IoT Continuum. We're really talking about the point of convergence between IoT, edge computing, and cloud, where we're moving from a discrete system to multi-layers and much more complexity, all the way from devices through to multi-cloud environments. Next slide. The EU Cloud-Edge-IoT is a really big ecosystem of tens of projects that are really pushing forward the envelope here in respect with what the technology can do and building the foundational blocks of what is the EU Cloud-Edge-IoT. And later on, you'll hear from the Commission, from Rolf Remmenschneider, who will explain a bit more in detail about how that is contributing towards the future and leading into what we call large-scale pilots. Next slide. So what we're going to talk about today, I'm going to finish up now speaking. So looking forward to a great session. I will then hand over to Rolf Remmenschneider from the European Commission, who's head of sector for IoT within DG Connect, who will give an overview of where they see SMEs opportunities in building out the grid edge. Then we will hear from Natalie Samovic, who's the chair for the Working Group of Energy within AOTI, and who will give us her bird's eye view of what's happening within research and innovation in this area within an energy context. And before handing over to my colleague Tanya, who will have a roundtable discussion with some industry experts working very closely within the energy sector to give you a viewpoint of exactly where is it that these organizations are looking for opportunities to incorporate advanced technologies, and what are the specificities and the particular nature of working within energy contexts. Then we will hear from 5 projects within the MetaOS who have opportunities for you to participate through funding. Between the 6 projects within the MetaOS, there's 4.2 million euro available for projects to participate in these type of areas between now and the early next year. And then we'll move into the use cases. So you will have short presentations from each of the use case owners. And the real point is for you to understand exactly what the use case is, and then to join them in an intimate breakout session that happens afterwards. So get an idea of what is the projects, the open calls, and the use cases, and you'll get to meet one-on-one with the use case owners and the open calls coordinators in the breakout sessions. And we have 2 rounds that allows you to participate with 2 projects. So we'll give you a chance to meet with at least 2 use cases or 2 projects how you see fit there. So without going any further, I think I'll now hand over to Rolf Remmenschneider from the Commission, who will be giving us, before I forget, where you'll find us next. So we'll be next at OnLit on the 29th of November in Paris. So if any of you are there, please come join our session. Energy Data Spaces, looking at the technologies behind it. And then also on the 4th of December is a hybrid brokerage session available for joining in the large-scale pilot, which is the next evolution of the EU Cloud-Edge-IoT. And I'll explain a bit more detail at the end when we close. So without further ado, then I hand over to Rolf. So Rolf, over to you.
Thanks, Brandon. Can you hear me?
Very well.
Very well. Good. Thanks so much. Thanks so much for the introduction. Good morning, everyone. I'm very happy to have this session today. Because it's an opportunity, particularly for smaller companies and SMEs who normally have some difficulties in joining Commission programs because of the overhead. But here we have a scheme which is quite lightweight, and I'm quite happy to have that matchmaking event to introduce, what we are doing over here. And today we are focusing on the energy applications or the grid edge, and I explained a bit more on the details. So next slide. So actually, I think you have seen it already. We started under Horizon Europe to support what we call a paradigm shift from cloud to edge to IoT. You're quite familiar, what is about IoT, connecting different devices, but most of the devices are linked to any of the cloud space. And now with the new opportunities in cloud computing and cloud paradigms, we see a new infrastructure coming up, what we call the edge, which has two elements. One is the orchestration of the IoT devices, but also, in order to apply cloud paradigms and cloud computing power at an infrastructure which is close where the data is generated. So this new paradigm has been introduced under Horizon Europe, and we support a couple of projects on different schemes, research schemes, along this along this computing continuum. So next slide. We see a big market opportunity, particularly in the industrial domain, for this new paradigm. Industrial edge IoT markets are growing over the next 4 or 5 years, particularly in professional IoT segments like automotive, electronics, factory automation, energy, health, and care. And for that, we try to push and support a European supply chain in that new opportunity. However, a European ecosystem faces numerous challenges because, the major IoT or internet companies, particularly hyperscalers, have experienced this new opportunity as well, and they're investing in that new domain. So we see increasing competition from hyperscalers, but we also it's an opportunity to reverse the trend of outsourcing of technology providers and ecosystems to Asia. So it's an opportunity for European companies to get a stake in this new computing domain. Next slide. We are funding a couple of projects, research innovation projects across this computing continuum, which cover a wide range of applications: manufacturing, renewable energy, smart buildings, logistics, railway, software-defined vehicle, farming. So it's a wide scope. Most of these projects have use cases and pilots and demonstrations in that area. And there's an opportunity for external companies to join this sort of discussion, to join the development and the use cases, and what we call over open calls. And that makes it interesting also, to promote it to newcomers, to get in touch with the new ecosystem, with the projects, to understand what is the innovation, what is the technology proposal from the projects, and to contribute. So next slide. So today we focus on what we call the energy edge or the grid edge, where we need a systems perspective. Grid operators want to have a stable grid, and that is challenged by the energy transition, by the crisis we have at the moment, by the investment into e-mobility, by increasing number of charging stations which require high currents and high power, on the spot, but also with the transition of building heating and decarbonization of buildings towards using more heat pumps. So we see there is a change, particularly in the usage. There is a higher share of renewables which create difficulties in the grid. We see a quantum leap for energy battery capacity, which is a huge asset also to be exploited by grid operators. And we see an opportunity, particularly for home and building providers, to combine charging, solar heating with mobility and building automation and comfort. So we see opportunities, particularly for newcomers, for out-of-the-box innovations, for smaller companies in order to contribute and to showcase what technology can do for this energy transition. Next slide. However, technology not alone will solve the issue. I think the main paradigm shift towards edge computing is also the change in the governance. And you will see here, a bit of a simplified sketch. If you have an increasing number of charging stations on cars attached to the grid, that cannot be handled centrally by a control room. It cannot be handled, that grid operators get access to the vehicle, and charge when they believe it's necessary. We see a much more decentralized governance model in the future, where you see a number of electric vehicles which are attached to the grid, but then then the charging is coordinated amongst them. Then we have some load balancing, that they do not generate a peak whenever they arrive at home, whenever they arrive after work and they all plug in, that there is an intelligence, in decentralizing the process and having a decentralized load balancing and avoiding problems and peaks for the grid operators. And at that time, you're also benefiting from renewable energy, meaning, starting the process when renewable energy or excessive renewable energy is available. So a complete new way of, governance of attaching assets, energy assets to the grid, but also coordinating assets among them. Next one. So with that, another sketch about the Cloud-Edge Continuum, we see more decentralized intelligence if we have more computing capacity, what we call at the grid edge, which is linked to eventually a home automation system, which then handles the load and the peak shaving. But at the same time, we have this sort of cloud connectivity and cloud intelligence, where new applications and new paradigms arrive, where you can benefit from new software and functions which could be deployed over the air. So we have to keep in mind, the whole continuum from the cloud as well to the edge until we arrive at the grid edge devices, meaning the heat pump or a home battery or solar panel, solar inverter or electric vehicle. Next one. So I think it was already mentioned and displayed by Brandon about a new IoT ecosystem, which is a complex one. Meaning, we don't believe that one company can solve that all, or that we have one monopoly, who can offer that whole service. It's a very dynamic, evolving service paradigms and technology paradigms, as well as a complex regulatory environment. So we see increasing complex infrastructure. We see evolving network connectivity and protocols. We had a meeting yesterday with Meta. You might have heard about it. Other protocols like eBus are at the verge of being introduced, and there are new connectivity standards approaching. So also we have new power of analytics, and using cloud analytics, using AI, but also transferring these analytics to the edge if we have more computing power. So we see there is a new ecosystem arriving, and that's why we have projects which are not one-stop off, which have dynamics built in. We launched about 4 million calls, open calls on the spot, which is continuous, and we will continue this ecosystem building over the next wave of projects, which will be launched next year, what we call pilots, and that has been already mentioned. Next one. What does it mean, a framework to spur of vibrant IoT ecosystem? Yeah, first of all, we have to manage complexity, and we think that appropriate approach is what we call an open platform approach. Open platform means that you can cope with more connected things. You can cope with more data on the spot, real-time data if it's close to the edge, that we have more possibilities for digital solutions and to analytics, to artificial intelligence eventually integrated at the edge, that we have an open ecosystem which can cope and integrate and mobilize more developers, which increases the community, which increases the services offered, the technology pace. We have more knowledge, more capabilities. We have wider solution catalog at the end of the day that will also attract more users. So this is what we call a platform approach. This positive cycle will create the value of the platform if we manage, to engage with more companies, more developers. So edge platforms particularly depend on this platform approach. Otherwise, we'll have a new infrastructure which will be somehow siloed and will not scale. Next one. So also this platform approach includes what we call open source communities. It embraces open source because this community has seen that opportunity at the edge already. There are a couple of projects, which are centered more on the edge infrastructure, but also which comes more from the cloud edge. I think you see a bit of a different sketch and how they are positioned. But definitely, I think these open calls are open also to open source projects, to bring in open source projects to the projects, and to mobilize a wider set of community. Next slide. I think here it was mentioned already by Brandon, so I skipped that slide. Next one. So basically, that's my last slide. The baseline for the open call is this paradigm shift from cloud to edge to IoT. We focus on these new technologies, which we want to bring to business. We want to mobilize external stakeholders to experience it, to contribute, to spur innovation and moving cloud processing from central servers to distributed units, to edge nodes. The main baseline, as mentioned, is an open framework for a vibrant IoT ecosystem, and the projects are there today to explain the technology, but also to tell you, where they are open, what they are looking for. Do they looking for more technology to test the interfaces, or do they look for more use cases to adapt their technology? So we have to do, for the upscaling, we need to analyze the cost-cutting aspects as well, like open standards, open source frameworks, open APIs, because otherwise it will be very difficult for external parties to join a project or to adapt what has been developed. We need a common architecture models. I think we are trying to train the projects to have an easy representation of their approach in a sort of a visualized and simplified architecture. And that are the main ingredients for underpinning the emerging open edge ecosystem. So next slide. And with that, I'm closing. It was mentioned already, we have a brokerage event on the 4th of December, where we move this platform approach from research innovation pilots towards innovation actions and innovation pilots. We're looking for large-scale pilot applications, and there will be an information event, a first brainstorming event, and possible ideas on the 4th of December. It will take place in Brussels, but it's hybrid. You also can join virtually. More information is on the portal, which is supported by the Unlock CI, which is also behind this organization of the day-to-day, and many thanks to the colleagues of the consortium. And with that, I pass back the floor to Brandon. Thank you so much, and wish you a stimulating day today.
Thank you very much, Rolf, and thank you for providing us with that overview of what we're talking about when we discuss Cloud-Edge-IoT and that concept, and also what the EU Cloud-Edge-IoT initiative is doing in bringing forward the different tech architecture and components, but also the chance today for everyone just to remind you to meet with these use cases and really understand how we're going from theory to application and be able to get under the hood and have that discussion. And you've got plenty of chances today. So the next person I'd like to call up is Natalie Samovich. So Natalie Samovich has many, many hats. So today she is wearing the chair of the working group of energy within the Alliance for IoT and Edge Innovation. And this is a very, very active community, and particularly her working group where they're really advancing to bring forward this edge computing and IoT into energy systems. Other than that, she's also responsible for research and innovation at Enercutum, which is a microgrid research center, and I think also angel investor and many, many other areas. So maybe, Natalie, I hand over to you now to give us this overview of what you're seeing across Europe in these areas.
Thank you so much, Brandon. Thanks for the invitation and ability to share the outcomes, some of the outcomes of our ecosystem work, which I would like to present today. I was challenged with the giving the meta-analysis of the use cases. And you see some of the keywords in the title. So the energy sector transformation, which is the key. So that part is moving. The use cases themselves are moving. Digital integration is moving. And as Rolf mentioned in his previous presentation, the European R&I as well evolving. So we have a perfect storm environment. And if we can go to the next slide. So I would like to give some insights into these 4 topics. They're not necessary in sequence because they're all interconnected, but I will share some areas of energy sector that are most ripe, let's say most urgent more than ripe, because there is bottom-up and top-down needs. In the digital technologies adaptations and the urgency of those. Then I also will give some insights as to the trends in terms of the evolution of the use cases within the energy sector, and some of the examples and the initiatives that are working currently to improve the digitalization and the data sharing, and as well as the orchestration of data across various organizations and the ecosystems. And the key levers and drivers are going to be incorporated within. Next slide, please. Yes, so what Rolf already mentioned, that the energy sector is transversal, touches upon many areas, and also omnipresent. So here I just wanted to outline the 6 areas that I think where the edge is currently evolving. So first area that you can see is the edge intelligence for energy efficiency. So the energy efficiency touches not only the buildings, not only the industry, but also efficiency of the operations within the energy sector and various environments. Then the second area I would like to outline is the edge analytics for the predictive maintenance. And here, the main emphasis is related to the predictive maintenance of the operation or electricity generation, but also all energy vectors related also to the sector coupling. And then edge computing for smart grids. This is very complex area because it touches upon all of the vectors that I've mentioned before, but specifically I will give a little bit of the deep dive on this and bring the ecosystem of a TIPSnet and high-level use cases linked to the smart grids in the next slides. Then we're going into the edge devices for worker safety and enablement. This is a new evolving area, not new as technology, but as applications. And here there are lots of interesting projects ongoing related to the drone-enabled maintenance and the related edge computing. Fifth area that you can see is the demand response and flexibility of demand overall. And one of the components is the virtual power plants. This area is rapidly evolving, and I would equate it something similar to the AI evolution, it was so the microgrids and the virtual power plants is not a new concept. Communities, research communities were working on it for the past 10, 15 years, but the adaptation, I think, is coming now. And the 6 areas that you can see is the digital twins, advanced analytics towards the data spaces. So the use cases related to these 3 areas are the most complex, and I think they touch upon all the previous 5 areas. What you see also in the center is a couple of reflections on the differences, because there is big debate whether there is a competition edge cloud and what are the differences. So for the energy sector, I think these are 2 other reflections, is the time sensitivity of computing, of volumes, and as well as the efficiency of computing and needs. And that's something that we're moving towards. Next slide, please. So I won't spend much time on all of the components because I think it was already covered in Rolf's presentation. Just to mention that when we're talking about the use cases, we have many layers of and structure of the use cases. So just to reflect on something when you look at this slide is, imagine if you're gonna have the equipment manufacturers having all separate platforms, which are not interoperable, which are not orchestrated, and that's the worst case scenario that we're trying to avoid. So it's not only optimization of the edge computing and data, but also the orchestration for the new services creation. Next slide, please. So as I mentioned before, here's the context of one ecosystem of ETIPS-Net. So ETIPS-Net is dealing with the smart grids, and the experts are authors of the roadmap of the smart grids. It's one of the European ETIPS and also part of the European ETIP forum. So what you see on the screen is the outline of so-called high-level use cases. There are 8 on the picture. It's part of the roadmap, ETIPS-Net roadmap, and 4 of the outlined in red are the ones directly related to the digitalization. So high-level use case 1 is focused on the optimal cross-sector integration and grid-scale storage. So cross-sector integration is one of the evolving and big topics, not only for the ETIPS-Net, but for many communities. And this is specifically outlined as one of the big high-level use cases. The second one, you see, it's the digital technologies for market participation for consumers. And here the focus is at the center. So it's not grid-driven, but bottom-up driven. That's the goal that is described in this high-level use case. High-level use case 9 deals with the flexibility provisions by buildings, districts, and industrial processes. And here the transversality of the vectors, basically, and as well as the context, the domain, building, districts, and industrial processes is very interesting. So that's where the additional complexity will lie. High-level use case 8 is focused on transportation and integration of storage. Rolf mentioned very good use case also related to the orchestration of charging, and that's one of the examples. If we can go to the next slide. So this is not the scientific exercise, but specifically for this presentation, I just wanted to achieve 2 things. So first of all, look at where the use cases repositories are in order to understand, how they're structured, where they're structured, who's sharing them, and if there is uniformity in the use cases per se, and also which ecosystems are dealing with the edge computing. So as you can see, the use cases group, just for simplicity, are divided in four: operations and maintenance, grid management, smart buildings, and energy communities. Under each of that, there is a plethora of other use cases and ramifications. So this is just for the purposes of aggregation. You might be familiar with the Bridge community, which is the European support project focused on data and in energy, and aggregates many projects that are working on the crossroads between energy and digitalization. And within Bridge, so there is a focus on all four areas. OneNet is another ecosystem. It's a project that also focused on building the interconnector between all players in the energy sector. And these two areas, or the project has use cases related to these two areas. BD for Energy is another ecosystem that brings the edge computing and as well as the analytics and AI marketplace, and touches upon all four areas. So Aerial Core is, I brought it up, it's also an ecosystem of projects focused on the robotics in operations and maintenance of grids. EPRI has very good repository and mainly focused on the grid management. It has different format and approach of the use cases as other communities, but worth looking at. Platone is another ecosystem focused on the grid management. And so we shouldn't only look at the European way of structuring things, but also keep an eye what's happening on the global level, and especially in the US. The system is different, but the use cases and how they're structured, it's also an interesting exercise to see what NREL is doing in the area. So Omega X is the first attempt to link edge to the cloud. So the Omega X project, which is the evolving data space project, also has a number of the use cases. IoT catalog is very much bottom up and components driven, and the use cases there linked to the smart buildings and energy communities. I also put here a retrofeed project, which is focused on the energy efficiency and elements of edge computing in the industrial environment, which is becoming more and more prominent and important within the energy context. And IntNet, I will have a little bit more information later on, so also focused on the grid management. Next slide, please. I think I'm missing the title from this one. I won't spend much time on this. This is a simple way, the way it used to be. So this is a retrospective of some of the use cases where we started with a number of years ago, but since then the complexity increased. That's the main message on this slide, but the title is missing. Next one. So just very quickly as to the main trends, and Brandon team, please let me know how much time left. I'm not following the timing.
2-3 minutes to allow time for any questions.
Great, thank you. So main trends. So first of all, hopefully I already managed to communicate that it is evolving smart sector integration environment. We're touching upon many domains. And also within this smart sector integration environment, we also have lots of new things coming up, and some of these are mentioned. Building directives, electricity market design, upcoming demand response code, EV charging rules, and hence it also directly affects the modes of operation, the business models, and the optimization of the business models and the solutions, the technical solutions that some of them Rolf also mentioned. So among very important things to mention, so I think there is a trend of increasing use of AI-driven models in energy sector. It is an evolving area, and looking into the future, optimization of of this at the edge and edge cloud is going to be very important. And of course, the digital energy efficiency. This is the first question that is being asked. Are we doing something that actually is going to improve the overall efficiency and not just facilitate one area? So I think we're all familiar with the main trend of decentralization of generation of electricity overall, and it will have the profound impact not only now but also in the future. And linked to that is the sector coupling. For the sake of time, if we can go to the next slide. Yes, so within the AOTI, we've been also reflecting on this high-level use cases and specifically focused. There is a series of papers that have been released and also ongoing, and one of them you see on screen, which is focused on the energy flexibility through the next energy sectorial integration. So now, within the context of what I explained before, you see how we approach it. Because AOTI is also transversal, we collaborate with the working groups, agriculture, building communities, ecosystems, and hence the position and the approach in this paper and other works we have is really cross-sectorial. So please have a look. It is on the website. There are 3 major blocks of use cases that we touched upon, and there are 2 more papers coming up, one on the digital twins application, and the third one, which is not going to be surprised, related to the AI models in energy. Next slide. Yes, so that's been already a good collaboration so far with SEI, and this is the outcome that was published by SEI, and we discussed it within the AOTI, fully in line with all these 6 areas, and I think the use cases will be stemming from this as well. I'm wrapping up, Brandon. Yes. So just very quick reflection on complexity of all of this. So we had very simple way of one-to-many in energy system. Then we started moving many-to-many model, and now it's really ecosystem to ecosystem. And we're moving from the IoT to data spaces, and also had the paper of AOTI related to how IoT enables data spaces. I think the work in this area will continue. And what you see on the top right-hand side corner is the picture from the AOTI SRIA that was recently published. So just to indicate where IoT Edge sits. And on top, you see the cross-domain focus and you know the depiction that it is really a cross-domain approach, but touches the almost 2/3 of the continuum. And I think I have the last slide. Yes, as promised, here is the some of the edge enablement challenges. I mentioned already the decrease of the CO2 footprint, overall decrease of traffic. It stands also for the energy sector, decrease of complexity of the solutions, and much faster and more efficient orchestration between the platforms, integration of the platforms, and the continuity of those. Increase efficiency for mission critical applications, because in the energy sector we have regulated and market environments, and that's another area of complexity. The agile approach of development, you've seen how the use cases moved along the way in complexity, and of course the decreased cost and the efficiency of operations. So these are some of the challenges. What you see on the screen is the set of the projects and the related CSA, looking at the data spaces, and they have the use cases related to the edge computing, of course, but it's the bottom building block is IoT still in those. So this is one of the examples of some of the ecosystems. I'll wrap up here. Thank you.
Thank you very, very much, Natalie, for giving us that comprehensive overview of where we're looking at the research and innovation in this area, and really how Edge is becoming pervasive across this challenge that we have in increasing the capacity of our energy systems and our grids. Do we have any questions for Natalie? Would anyone like to raise their hand? No, in that case, I'd recommend that you connect with her and connect with what AOTI is doing in this area. And also, oh, Tanya, you have your hand up. Go ahead.
Thanks, Brendan. Yeah, Natalie, I think that you've got a very privileged view of the whole of the energy ecosystem across Europe. And thank you for sharing some of the learnings and the things that you see from that 30,000-foot view. What do you think are the biggest obstacles to collaboration across different energy ecosystems? Because I think that sometimes we explain things as if there's a single market for energy, but actually in practical terms, that is very, very far from the reality. So could you maybe speak to that a little bit about, having that single energy market across all the different EU member states? What are the main obstacles, and what do you think would be maybe some of the solutions also? Thank you.
Thanks for the question. I think one of the projects that I can mention that is trying to deal with that, the topics that I did not mention, but they're kind of underlying, they're on the level lower, TSO, DSO interfaces, so transmission system operators and distribution system operators interfacing and coordination, and of course that happens on the digital level. So that's one of the projects. What they're doing is building the interconnector, basically, that would allow integration of services, and that is built on other ecosystems like IDSA, integrating the common architectures as well. So this is one of the efforts. But beyond that, there is also interface between TSO, DSO, and consumers, right? And the aggregation of those consumers on various levels, like energy communities is one of those, but also interfaces with other sectors, such as industrial sector, for the flexibility of demand. That's why I mentioned one of the projects in the area. So the one of the answers, based on what I mentioned, is complexity is really pervasive, right? And so we have the coordination first on the electricity grids, on the continuum that I mentioned. That's one. And then we have interfaces and sector coupling. So some of the recent work that we've done at TIPSNet is looking at the sector coupling, and not only from the energy vector, but also from the digital integration and coordination. To answer your question, how we can improve, I think with the projects like SAY and interfacing the communities, that's one of the ways, because I've already shared the outcomes that I put on the screen with the energy communities, and it was quite impactful, because we can actually calibrate topics related to the open source. There are lots of questions on that, on the orchestration of the digital platforms, on the community, on the data sharing, and this dialogue is necessary. So that's the only way forward, I think.
Thank you, Natalie. Thank you, Tanya. Rolf, a comment from you or a question?
Yeah, thank you. I just wanted to compliment, I think, thanks for the question. The cross-sector approach also drives us and keeps us sleepless nights. I think Natalie mentioned the different ecosystems. It sounds good, no? Different ecosystems, and but it's not 1+1. I think you need agreement on interfaces, APIs, and standards, and that doesn't fly from the sky. It's hard work, because we really have different cultures and ecosystems. And I want to add that our unit is responsible for the implementation of the data spaces and the implementation of the regulatory framework for data. So the data strategy is one element which has to be implemented in different ecosystems. And then you need, for data sharing across ecosystems, you need agreed strategies on how to exchange data. And that is only one part. And the other part is, as I mentioned today, at the end of the day, you have to control systems. Electrons have to fly and the grids have to be stable. So you need a system approach which gets across your comfort zone, across different established stakeholders. And that's what we call the platform approach that we want to push with the pilots. So I think we have different dimensions, definitely, and huge challenges ahead.
Absolutely.
Great, thank you. Sorry, Natalie, go ahead.
Just very one sentence on the data sharing, right? So now for the flexibility services, there is a big topic of onboarding companies, onboarding services providers, and so it's beyond only the APIs, but it's also on the topic of governance, right? And orchestration of data sharing. Specifically, I can mention the issue of trust. So who has the access to what and how? So it's quite complex beyond the platforms. I fully agree.
Great, thank you, Natalie. And that gives me the perfect segue to the next session that we have with Tanya. So Tanya comes from BlueSpecs. It's a member of the Unlock CEI, and at BlueSpecs, we support the adoption of advanced digital technologies. And she's going to be speaking specifically with people from the industry who will be able to give that realistic view on what are those challenges when we are integrating, and what is it that we need to be looking for within these energy use cases that we are moving forward along the way. So Tanya, if I hand over to you to the introduction, and then we'll take away the slide once you're finished so we can see your faces.
Thank you very much, Brendan. And I would like to thank both Rolf and Natalie for a perfect introduction and scene setting for this next session. So we're going to be talking about powering the future, tech transformation of the energy sector and full transition. And what we want to do is again contribute to setting the scene for what will be the open calls that are coming out of the projects that Brendan mentioned briefly in his introduction. And as part of that, I think that we're going to be drawing on quite a few themes and topics that both Rolf and Natalie have outlined, everything from the role of open source, what is it that we need to be securing through these open calls, things like, the stability of the grid, how can we make sure that the next generation of the energy market is really is distributed as it possibly can be, but also is reliable and serves the needs of citizens and businesses across multiple sectors and across multiple geographies as well. So having said that, I would like to welcome my esteemed panelists, Selene Livrani, Senior Technology and Projects Advisor for DSO, European Distribution System Operators. Valerie Ann Lenksnar, she's a senior advisor. She has, like Natalie, multiple hats. Dieter Young, sales lead, finance, HR and legal at Rialto Energy, and Nicholas Honig, co-founder at Citer. Now, could I invite you all just to give a bit more of a description of what it is that you do within your organizations? And then we'll go into the discussion of the panel proper. So I'll call each of you out. So Selene, if I could invite you first, please.
Yes, hi, thank you very much, Tanya. Just checking that you can hear me fine.
We can hear you perfectly, thank you.
Thank you very much, and nice to be here with you today. Yes, as Tanya said, my name is Selene Livrani. I work at EDSO, which is the Association of European Electricity Distribution System Operators based in Brussels. And I specifically work together with the Technology and Knowledge Sharing Committee of ours, which has the aim of fostering innovation in the power distribution sector by offering an arena for debate about technological developments among our members, but also in cooperation with key players in the industry.
Thank you, super relevant. Valerie, please.
Yes, good morning to all. So I'm senior advisor at RTE. So RTE is a French transmission system operator. So it is a TSO, which is regulated. We have 100,000 kilometers of line and 9,000 employees and 960 direct customers. So what do? We provide electricity 24 hours a day. We accelerate transition by adapting the grid, and here we are with IoT solutions, and we help also authorities by publishing some forecasts. And I'm also ambassador for the Global Smart Energy Federation, which aims to accelerate the deployment of smart energy solutions around the world and fosters the international exchanges and best practice in the smart energy field. Happy to be here with you today.
Thank you, Valerie. And I think just maybe something else that's very relevant. Valerie is also a jury member for the European Innovation Council. We've served on juries together. So I think bringing that perspective also into discussion will be very, very interesting. Dieter, welcome.
Hi, welcome. Hi, I'm Dieter Young. I work at Rialto. Rialto is trying to bridge sectors by applying IoT technology. That means we basically integrate APIs of cars, heat pumps, solar inverters, battery inverters together into a platform. So more or less exactly what Rolf was describing as a major challenge. We're doing it every day. Yeah.
Thank you. Dieter, could I ask you to put your volume up a little bit as well for the next part of the panel? Thank you.
Okay, thank you.
And Nicholas, welcome.
Hello. Can you hear me?
Yes, but if you could also put your volume up a little bit, please, that would be fantastic. Thank you.
Yeah, I will do that right away. Here. I'm Nicholas. I am co-founder of Saita Energy Flexibility. We are on the cloud side. That's why I'm complementing Dieter. We do smart energy planning, and specifically we use open source software that we donated also to the Linux Energy Foundation that sits in the cloud. We use it both for digital twin approaches, but then also for the real-time energy management orchestration. We're working on e-mobility right now, but also on smart heating. And the sector coupling is actually our next goal. The customers we work for usually are ESCOs, or energy service companies. One I would like to pick out is energy advisors who are planning projects. So mainly we work on smart buildings right now to design the energy project and then run them optimally. But we've also had 1 or 2 projects already in the industry.
Thank you very much, Nicholas, and again, welcome all. As you know, the EU Cloud-Edge-IoT ecosystem is going to promote the establishment of a global and open ecosystem for CEI technologies. And we're going to be hearing a little bit later about what those different projects entail and what their specific what they bring to the market very specifically. But if I could maybe ask you all to help us to understand like the broader context in terms of understanding what technological changes are needed to meet the energy needs of the future. So just taking a step back and from your wealth of experience of working in this very peculiar market. Valerie, perhaps if I could start with you. In your experience, what have been some of the biggest obstacles to actually understanding what technology needs to be brought in to meet the energy needs of the future?
Mm-hmm. Yes, thank you, Tanya. I think that for many years, the TSO and DSO industries didn't need to digitalize because everything was working very well. And it came quite recently. But now I think there is an awareness in Europe, and I would say also at an international level, that there is an awakening that digitalization is really needed, that we cannot just, monitor the flows without some very precise measurement. Also because energy has to be saved. And we have seen that during the Ukrainian crisis this winter. We are going to see that still this winter also. So flexibility becomes the main topic for TSOs and DSOs. Also because there are some societal changes, sobriety becomes a lever for I would say, all the stakeholders, not only the energy companies, also citizens, also political authorities. So we need to answer to that need. So I would say that today there is no major obstacle in the sense that all this awareness is made. If I could quote maybe only one, I would say this is maybe the fact that our infrastructures are critical. And it means that our providers need also to adapt to our standards. And we have also, of course, to reinforce all the cybersecurity measures.
Thank you. So two very concrete things there, apart from more broader societal and, should we say, political changes. There's no obstacle per se, other than the fact that we need to, other in inverted commas, we need to be focusing on standardization was one of them, but also cybersecurity, because we're dealing with significant infrastructure, so critical infrastructure. So Len, would you like to complement that?
Yeah, absolutely. And I think I can resonate with what Valerie said. Right now, we're seeing a lot of very rapid and fast-paced changes in the energy system and in the power system. And we've seen this morning how this is becoming growingly interconnected with traditionally separated systems, such as the mobility, the building system, and we've mentioned them this morning. At the same time, I think that the picture is complicated by the fact that there are some technological trends and innovation that are also making their way into this picture, coming sometimes from different sectors. Natalie mentioned drones this morning. This is a very good example. And a key aspect here is also understanding what will be the impact of these trends that are emerging on the power system, and what is the potential, but also what will be the challenges that come with them. And this is, if I may, something we are really looking into. And so we have recently published a technology radar. I will share the link in a while before leaving the floor to the next speakers. But because it's key to understand now what will be the impact from these changes that are taking place, and identifying what are the risks and opportunities that come together with them. And this fosters not only helps us, but fosters cooperation in this industry as well, which is something really needed.
Thank you very much. Nicholas, would you like to speak to that? So there's a need for collaboration. There are new markets that with new demands on the energy system. There are new subsystems coming in. How are you finding that collaboration? Is there a change needed there? Is it happening? You know, is it all working well? What's your perspective?
Well, I've been in this field now since 2009. So I changed my role. I first was a PhD researcher looking at this at my topic, the smart planning of energy flexibility, for a couple of years, and then I switched to the market side, and I was really trying to feel out when does the market really react, when do people pick this up and want to collaborate, want to invest in well, paid pilots, but then also going further. And yeah, it has been a long 14 years looking at it, but we of course have to see how big this transition is, and also what's mentioned before, that people are reluctant to change this system that has been working well, and that they didn't have to pay much attention to. One added observation I have is that we had to remove a lot of doubts about affordability of solar. Are electric vehicles a good idea at all? And all of these, I think most of them have been removed. As yeah, I agree with that. There's no big doubts on technology anymore. But now the trends of electrification and that the renewables really hit the system, I think they're almost at the breaking point. A lot of the potential customers I have finally have a problem that makes them collaborate fast, which is their limited grid connections. At least here in the Netherlands, that's one of the topics, that you need something that ignites collaboration or ignites market uptake, and the energy prices haven't been it yet. So you can make a big difference, but it doesn't spur action enough.
Thanks, Nicholas. That's really interesting, because typically this is what's always said, particularly in the circles that we move. So you need a big problem that costs a lot of money for people to collaborate. But what you're saying is actually the cost of energy is just of itself not enough. There needs to be something that is much deeper to ignite that collaboration. Dieter, would you echo that sentiment?
Yeah, to a certain extent, I would say yes. It's definitely so that consumers are quite price inelastic, which makes for the lack of what they would typically call willingness to pay in these business models to develop this infrastructure. I would say as well that I think my main barrier that we run into is usually micro-regulation. So to a certain extent, you need regulation to get this new technology to work, to get it approved. Give you an excellent example is the EU Data Act. It's going to open up data of appliances to third parties and to end consumers. I think that's excellent. It's very high level, it's very broad, but it gives a direction to the industry. What we run into, for instance, is micro-regulations like actually every car today has an API. No car today has an electricity meter on board. Why not? Because there's a whole lot of regulation that you need to apply to if you want to install an officially recognized electricity meter on board. And car OEMs simply want to build cars. They don't want to build electricity devices for us. And they will keep on building cars for the next 20 years without caring about the electricity system that they have to plug into. So I think that's a typical example of micro-regulation that stops it. If you see all the incentives giving to smart charge poles, for instance, across Europe, because we like smart charging and we've somehow made smart charge poles the industry standard, whereas that might not be the standard. I think if you look at the biggest electric vehicle seller in the world, Tesla, and they actually say, put the intelligence in the cloud and in the car and don't put it in the charge pole. So if by micro-regulation you impose a certain technology, then you'd rather be damn sure that it's the right technology that you're proposing. And I think that's what we mostly run into on a daily basis, especially with this new IoT technology, which is fairly unknown, fairly uncommon to most business models. And yeah, it's a challenge.
Well, actually, just picking up on that then, because you've brought in the question of IoT and what it brings to the ecosystem, whether it's a benefit or sometimes an obstacle, because people or organizations don't really know how to deal with it within the context of their particular domain, but also the interconnection with the energy subsystem, if you like. So from your perspective, if we could carry on with you, Dieter, what does the CEI continuum mean to you, and where does it have the potential to have the most value, do you think?
Yeah, I think I've said it before. I think I like it when you propose it as a continuum. I more see it like a battlefield of new and emerging technologies trying to get there. I mean, let's all be honest, electric vehicles are not the standard yet. So charge poles are not yet at market maturity, and we're already attacking the technology of the smart charge poles to replace it by IoT connectivity in the vehicle. And then probably somebody else is going to come with a blockchain-based car data sharing model, which is then attacking an API-first economy. So I think it's more or less, there's a lot of solutions to the problem out there. I think what we all agree upon is that it needs that we need the data that is applicable to be used in the system as general. And so that's why I think it's important to have regulation that unlocks the data, but at the same time, don't have the regulation that prevents certain technologies from developing itself. And I think that's a very tricky balance to strike as well. I think if we look at the continuum, we can also find it in other sectors, like for instance, typically your solar inverters are very well connected, tends to be battery connected, so the battery inverters that are also very well connected. If you then move to heat pumps, it's a bit of a more, let's say, immature technology for the moment, although some brands do stand out. But you can see that there's a continuum in each line of the technology there. There's charge poles that are way ahead of others. There's blockchain initiatives that actually are already commercial. There are others that are still in a very premature of technology. I think in the entire continuum across technologies, you can find different maturities, and that's a bit hard, I think, also from a regulation point of view, to take the right action there. I think that's a big challenge. I see Nicholas nothing, so I think he might want to add to that.
Yeah. Can I, before coming back to you, Nicholas, because I want to pick up the analogy of a battlefield rather than a continuum, and I want to ask Valerie to, from the other side of the market, do you see it as a battlefield? I mean, how do you, as Dieter's suggesting, how do you select which technological solution is the one to trial? Because deploying something even within a paid pilot or within a relatively protected use case or testbed facility is going to require a lot of management time, a lot of resource, kind of bringing different resources, and of course you're going to have to be able to measure the impact versus a different alternative. So is it a battlefield? How are you dealing with that complexity of offer?
Yes, rather than confrontation, I prefer to use the word collaboration that was used also before. It is true that there are less resources, that the complexity is increasing, and so what are the solutions? The solutions are to work together. And this is why, for example, RTE has been creating the energy branch of the Linux Foundation in order to increase the collaborative work between players, between stakeholders. So today, for example, Alliander is also a member of this alliance, and there are lots of different softwares that are developed all together. So one comes with a specific issue, for example, about the monitoring of the grid, or about some simulation regarding what will be the balance at some critical moments during winter for the electricity system. And then this company asks to others, do you want to work with me on that topic? And once it's done, it's public. So this is the magic of open source. And I think that today, for me, the main message is that we are just at the beginning of this kind of process. There are still lots of things to do together. And the scarcity of resources pushes us to collaborate far more than before.
Thank you, Nicholas. I think that was QU, because especially with the mention of the Linux Foundation and the open source components, have you found that to be an enabler of access to different markets? Have you found that to be that collaboration to really help you understand how you can integrate and where you fit in the battlefield collaborative arena?
Yeah, it has been helpful. It also creates trust. That's one of the first things. The Linux Energy Foundation imposes a governance. There's security checks on our software regularly. We have needed to have open conversations. There have been collaborations on conferences. That's great. I agree that collaboration is needed in addition, of course, to the competition, the healthy competition that we should not let go away. There's also competition within the open source world. We don't want for something just one standard. There should be always 2 or 3 things that are alternatives. And on the topic of collaboration, it's still a bit of a high level. If I continue my story, that I've been looking at all these topics slowly becoming more possible over 14 years, while 2009 it was clear that this is a very likely scenario where we find ourselves in now, but we haven't made the big steps. In the meantime, it's still clear looking ahead that we don't have a lot of time, right? So if this was just something that should happen, but we give the market enough time, however much time is needed for everybody to come to the table in whatever form they see fit, we could have more patience, right? But I have a vision on what's going to happen that's also just based on well, climate science, but also the plans that have been laid out by almost all the big organizations by now, that we have, let's say, 15 years, give or take, to do one of the most giant sweeping transformations in basically all the countries, and the ingredients are clear. So I see the market as probably growing much faster than anybody can grow on their own anyway. So the case for radical collaboration, which we have taken by radically opening what we're doing, or a lot of what we're doing, is that this is not a normal situation. This is so rapid that collaboration it can be an imperative. But I see some people realizing that and coming to the table, but it's not a big understanding yet.
Thank you, Nicholas. Selene, maybe, and I've seen there were a couple of questions from the audience, so I want to leave a couple of minutes perhaps to pose those. But Selene, what do you think are perhaps some of the most important things that somebody wanting to come in with a solution? So we've got some open calls that are going to be published. What are the most important, if you had a top tip to give somebody who wants to come and work with the energy, in your case, the DSOs, what is it that they should take into account?
Yeah, thank you, Tanya. I think here the key word is use case, really understanding what is the need on field that needs to be addressed, and developing and providing a solution that can address that need. And I also think at the same time is a matter of prioritization and optimization of the resources that are there. Of course, full digitalization would bring great benefits, but if we look at the fast reaction with which we need to reply, to respond, to change, we need to start from somewhere. And this putting in place everything that is needed for digitalization, from deployment of devices to setting in place the right infrastructure, to having the right skills, because this is a very important topic as well when it comes to companies, having the right people who can deal with this increasing complexity. It requires time and requires huge investment. So it's a matter of understanding how to optimize with the time we have, the resources we have. And I'll bring an input that I got from one debate we had with our members on the topic of IoT. One of them brought up the concept of minimum viable product. So we don't need to have something perfect in place right now, but if we have enough feature to improve the process and respond to the need we have, we start from there. We start a trial from there, and then we improve it on the way to large scale rollouts.
Thank you, Selene. Maybe just picking up on that, what about the financials? Does there have to be, I think, I can't remember, I think it was possibly Dieter who was, or possibly Nicholas, who was talking about the fact that it's not just about the energy prices anymore. It's much deeper than that. When it comes to deploying or proposing a use case, how important is the financial feasibility versus perhaps the technical feasibility, or the actual impact it's going to have, for example, on a stable grid? How do you prioritize? Because you said prioritization, but how do you prioritize? Selene, that was to you.
Sorry, could you just repeat quickly? I got the name of Dieter, so I disconnected a second.
Yeah, no. It was somebody said that it was no longer about the energy prices. So you mentioned prioritization. How do you prioritize which use cases, or how do your members prioritize which use cases they're going to be investing in? Is it on the basis of the technology? Is it on the basis of criteria, for example, such as technology being able to stabilize the grid? Is it financials? What is it that you use to prioritize?
Yeah, Yeah, no, I think this is a very good question. I think, first of all, there's the definition of the need and the use case itself, and then keeping in mind that what's the ultimate goal, which in our case is ensuring a reliable and secure supply of electricity. Then it becomes a matter of prioritizing these use cases according to the business use case, and then is it a positive business use case, and then we put it in the pipeline. And I think that's the way to go.
Thank you. Valerie, could you perhaps provide a different perspective on that? You know, how is it that you choose, if you have 20 different MVPs in front of you, what is it that's going to make you choose one over another?
Well, I think we have to come back to our mission. So our mission is to provide electricity 24 hours a day, to have no blackout at all. So I think that, yes, we would probably choose the MVP, which help us to be close to this, to avoid any cut on the grid, and to be helpful also for the peak periods. And then we come back to the flexibility issue. So what is important in order to on the demand side management of the grid.
Thank you. Nicholas, is that something that you're seeing reflected in how your clients are making decisions?
Yeah. They still do like the combination. So this is more the actual smaller parties who have investment decisions to make in a market. And I understand the DSOs and TSOs also have investment decisions, but it's a slightly different paradigm. And I think it's just a matter of what really brings you to take time to discuss a project. And that's the looming grid capacity limitations that you cannot expand. You cannot expand your, for instance, if you want to place solar panels. A very good case is charging hubs. So if you have a logistics part in your business operation, and now, for instance, City of Amsterdam tells you you cannot drive diesel cars into the city anymore with your buses for delivery or for maintenance work. So now they think about adding 10 charging poles and suddenly realize that won't actually be possible. I won't get, in the traditional way, I won't get my grid capacity increased unless I provide a different kind of solution, which has a more smart and flexible planning to it. And when you're at the table then, because before that you could ignore it, you could always say, well, we always have 6 to 12 months. We can always do it later. And then when you're at the table, then you definitely bring in the other financials. Okay, what should we have a dynamic tariff? What is the difference that makes? Then we bring in our software first as a digital twin, and then we can show that. So it's a chain. It all belongs together. It just matters what makes somebody talk and basically devote some of their time. Everybody has a different business priority. Nobody's first priority is energy in the market. It's mine and RTE's and Dieter's is, but all the people who need to chime in or collaborate by what we do, they don't want to think about it. So for them to take that time to have a 2-hour meeting at first, to break that ice, the peak problems and the grid capacity problems are great.
No, thank you. And Dieter, from your view and from your experience, what unlocks that collaboration? And I think really importantly, what makes it go from a nice use case to then kind of full-scale implementation? Because I think that, obviously, assuming that results are as expected, it's not just about getting, and that's definitely not the purpose of the open calls. Will be there to test architectures. They'll be there to test that integration, that delivery of value to the end customer, and to the and to making sure that the grid operates correctly. But beyond that, what is it in your experience that unlocks that really, really long-term collaboration that means that you can continue to exist as a company and also look for the next opportunity, the next iteration on the technology?
I'd say consumer awareness. I'm pretty sure that, like Nicholas just said, I wake up and I go to sleep every day by thinking about energy. My wife doesn't like that much, and I think she's more of the representative panel for the rest of the consumers. So I think the majority of people just don't want to think about energy, and the solutions we bring. I think there's been numerous cases already across the past decade that have shown that there is actually consumer value into this, but if they don't want to buy because they don't understand why they should or how they should, then that's obviously a problem. So I'll give you a very short example. We started with a platform, an API-driven platform that wanted to enable people to build smart charging or smart energy management solutions. We ended up talking to the energy industry, who said, well, we can't find consumers that want to pay. Then we started talking to large B2C players who said, well, we want to do energy because there's an energy crisis and everybody wants to know anything about energy, but consumers don't want to pay. And in the end, we found a need where it's actually, insurance companies and fleet operators want to pay for connectivity to cars, to pay for basically getting state of health and odometer readings from cars, which is a tiny use case compared to what they can do on energy, but they don't care about energy yet. To them, it's they have different, like Nicolas said, they have different business priorities, and that's what they play into. And I think that kind of prioritizes how we develop the technology. It's looking at what does the consumer want and how can we, let's say, bring energy as a service without him having to become an energy expert. And it's a bit of a difficult dilemma.
I think that's a very good point, actually. You want energy to be like hair. You want it to be there. You don't want to have to necessarily think that you can't afford it or that you won't have access to it, as Valerie says, 24/7. So that's, I think that's, you've just brought the conversation, I think, full circle. So now I'm going to turn some of the questions from the audience. So first of all, we have a question from Paul Van Cotton. What do the speakers see as the biggest barriers or issues to co-conquer the energy flexibility space? So this is very specifically about energy flexibility. Valerie, could I ask you perhaps to pick that question up?
Yes, so regarding the flexibility, I just wanted to raise your attention on the one challenge that is done for the sector.
I think we've just lost Valerie. Valerie? I think we've lost her connection. So Len, perhaps would you like to take that question and we can come back to Valerie?
Yes, yes, of course. I think actually this.
There we go. Valerie, just your connection just dropped there. So if you could just repeat that, please. Thanks, Helen. I'll come to you.
Excuse me. So yes, this challenge is about how to make more savings in the buildings, because we know that today the most important source of savings regarding flexibility can be done at the level of buildings, either residential or, of course, office or tertiary buildings. And so this challenge has been launched last year. The name is Cube Flex. I will write you the name in the chat. And the idea is how companies in France can use the EcoWatt signal to gain sobriety on their consumption. So EcoWatt is a signal that is made by the French TSO, RTE, in order to create an attention for the consumers to understand that we are on a peak period, and that they should try to decrease their amount of savings. And the results are really incredible, because some of the companies have been gaining like 30% of savings at some moments applying the different principles which were brought either by RTE or by other companies that were participating to this challenge. So it's a very so here we can find the value of providers working, providing solutions for the IoT cases in order sensors, platforms to monitor the consumption and to decrease it at a very clear moment, which is actioned by a signal. I hope I answered the question.
Yes. No, I think you did. And I think that this, again, picks up on something that Dieter was mentioning about consumer awareness. And Dieter, there's a question I think that I would like to direct to you, also from Paul van der Kotten. Is it useful to involve citizens in the grid balancing domain by stimulating or subsidizing the investment in home batteries, or is this suboptimal? And I think, Nicholas, if you can come in, because I think that you also mentioned batteries. But first of all, Dieter, on the consumer side, please.
Yeah, it's a pretty good question, and it's down to a problem that we haven't solved yet. Is depending on what scale you want to do the optimization, whether you want to do it for an entire grid, for a subgrid, for a household, or for an individual appliance. You might get different results, and this is a bit of again this example of the battlefield. I like that everybody says that we're going to collaborate, all of us, but we're five people trying to drive the same car, and if the one wants to go left and the other wants to go right, it's a bit difficult. So depending on where we put the center of optimization, a home battery makes sense. But then again, probably if you look at it from a technological point of view, putting one big battery at the end of every street is probably technologically more sane to do. But yeah, in a free market, that means the entire street has to decide for themselves, or the DSO has to decide, which means the entire society is paying for the one street. I mean, it's a bit of a difficult question to answer whether a home battery is a good idea. If you, because the framework of where you want to optimize is not entirely clear, and what the consumer wants is also not entirely clear yet.
Actually, that's really interesting, Dieter, because it's the opposite of what in economics is called the tragedy of the commons. So it's the reverse of that. But we've only got a couple of minutes left. So Nicholas, specifically on the batteries, what's your perspective?
Yeah, I'm not bullish on the residential market right now, because as you just said, there's unsolved problems, and this is one of them. And maybe some kind of aggregation concepts would help. Like there's energy cooperatives as an idea, and that's being pushed, right? I think there's lots of research ideas on that, and we also joined some consortium. You might also have some low-hanging fruits, like larger buildings with like 50 apartments or so that can be run as one, let's say. So there's a couple of solutions that I would try first. We are looking at, I think the investment, it's not just a technical problem, also the investment problem of putting a battery, installing it. You run into a lot of cost already. It's like installing 3 solar panels on your house. You have manual work and labor and connection, and I don't think financially you get your returns fast enough. We should try other stuff. We should look at the large buildings with larger stuff on top, and start with that fast right away.
Thanks, Nicholas. And could I also encourage you all, there are a few more that Natalie's posed a question, Rolf has made a comment also in the chat. So we have to close the panel now to make sure that we remain on time. Otherwise I'll be having to answer to the colleagues here. But I would like to encourage you please to provide answers in the meeting chat. And it just remains now for me to thank Selene, Valeriane, Dieter and Nicholas for a very informative panel, and look forward to being able to perhaps repeat this in the future. Thank you very much, everyone.
Thank you.
Thank you.
Great. Thank you, Tanya, and thank you everyone there for some really great insights and directions. And actually, I think you'll be you'd be pleased to see that when our use case owners start to present a little bit later, some of the elements you were talking on there will be discussed and exactly what they're working on, including smart building management and also electric vehicle grid VTEX applications as well. So really looking forward to that. Right. So next part of the session is the chance for you all to participate in what we call the EU Cloud-Edge-IoT. So we've got 6 projects. So there's Eros, ICOS, Nemo, Nefele, Nebulous, and Fluidos who have open calls available. So if I go to the next slide, just to give the overview. These 6 projects, which are part of the MetaOS, so providing that orchestration layer between the devices and the cloud, are looking for you to participate in their projects. So they have between them 4.3 million euro available for around 40 engagements between closing in a week's time to March. So between now and March is your chance to really get involved. As you'll see, ICOS and Nemo are the first ones. Eros is also open. Nefele is about to open. Fluidos will be opening in the new year. And Nebulous will be finishing up after Fluidos as well. So any information you want to find out, they're going to now give you a small presentation on what's available. And in the breakout rooms later, you can meet with them to find out more information in detail, where they'll be able to go over exactly what's in scope, what's out of scope, and to understand what's the best fit for you. So do take note of the next few presentations. For those of you who aren't familiar with the terminology, just to give a very brief overview, and Rolf has already covered this, this is actually a mechanism that's really important to allow different actors to participate with less overhead in this way. It's called formally financial support for third parties, and it's where the consortium who has received funding from the European Union is able to then give further funding to other organizations. So the relationship will be between the SME, the research center, and the consortium, and building out, either exploring how they can incorporate what they're building within their tech stack, and also expanding out the different use cases. So you will find information on the EU Cloud-Edge-IoT.eu and also on the individual websites. So to start off, within very 2-minute overviews of what the projects are doing, can I invite Nacho from Eros to give us the quick overview of their open call opportunity.
Hello. Good morning. Can you hear me and listen?
Yes, perfectly. Go ahead.
Okay, great. So thank you very much, Brenda, for the presentation. I know I have just 2 minutes, so I will just go straight to the point. I am here to present the open calls that we in the project Eros are opening for you to present on. We're basically looking for small projects that will validate our technology and our use cases. And considering the target audience today, we must mention that we have 2 use cases that are related to the field of energy. You will have the opportunity later to discover what those are about and how you could contribute. In terms of the contribution, if you are an SME, an RTO entity, you come from the academia, or you are an individual, you can apply for 60,000 euros in a single project with a duration of 8 months. And in the first open call window that we have now open, we plan to fund 7 projects. We have 420,000 euros. This is my contact, and I will be the one that will be managing the process. So if you have any doubts, you can contact me. Next slide, correct. The current open call that is open will close on 31st of January. It will undergo then a 2-month evaluation process. You need to prepare certain documentations, in particular, 15-pager proposal exposing your ideas, exposing how those fit our goals in the project, how those are specifically, in your case, related to the energy innovations that you plan to perform. And then this will undergo independent review by 2 independent reviewers per each proposal. And well, basically, you will be evaluated, and we will communicate you if you have been granted or not. These are some hints and some pictures of what our architecture is about. You have much more information in our webpage, in which you will find also a section of questions and answers that you can look to. In essence, we just aim to receive innovative proposals, short ones, to be developed in 8 months period, and up to 60,000 euros of funding related to our technologies and our use cases. And I will just pass the floor to the next ones. I am at your disposal and talk to you later today.
Thank you very much. And a reminder, Nacho will be waiting for you in breakout room 1 if you want to go and ask further details, and he can go into more content about not just the open call, but also the tech stack and components that are available. Thank you. Elena from ICOS.
Hi, everyone. Thank you, Brendan. So, operating system of ICOS.
Sorry, Elena, I have to stop you there. Elena, your connection's too poor. We'll go on to the next one and we'll come back to you if you can just see if you can fix your connection. So if we go on to, in the meantime, if we go on to Nemo. So Demetrius.
Yes. Hello, everybody. Hi, my name is Demetrios Skias, representing NEMO project. So what NEMO envisages to build is a meta operating system. We'll go to the next slide, Brendan. A meta operating system to support artificial intelligent IoT hyper-distributed applications into the IoT Edge Cloud Continuum. So for that reason, we ask for SMEs active in edge computing, edge and cloud native software development, operating systems, IoT 5G networks, and IoT manufacturing to apply for our first open call. The time window for applications is open and will close at the 30th of November. So in total, we ask for 6 projects. 6 projects will be selected to participate in the project and will be funded with 150,000 euros. The duration is 18 months. And what we ask is to provide, for the applicants to provide us with meta architecture extensions. So we plan to extend the scope and the technology, let's say, dimension of the project by providing implementations of software components relevant to the network, resource metering, automated controls, etc., or to port NEMO into new heterogeneous devices, IoT devices provided by the applicants. If we move to the next slides. So the projects, in short, will start the 1st of March 2024. So after the submission time, proposal window closes, we'll evaluate the proposals and then we'll start next year on March. 4 use cases or 4 pilots are realized to our project. So in these pilots, the project should validate their solutions, and this includes smart farming, precision agriculture, smart energy and smart mobility, smart manufacturing, industry 4.2, and smart media and XR. And some, let's say, highlights of the components architecture built within NEMO projects include the service management layer that allows for deployment of intent-based IoT applications. The NEMO kernel that realizes, let's say, orchestrates these deployments and migrations over the continuum. And the infrastructure layer that we have here will provide an abstraction over the Cloud-Edge-IoT infrastructure. Also, we have some vertical layers that contribute to the architecture and provide functional enhancements in the topics of cybersecurity, policy enforcement, and machine learning operations. So we will be pleased to have you in the breakout rooms for more details on the project, on the open calls, and on the particular use cases that we realize. Thank you very much.
Thank you, Demetrius. Elena, do you have your connection again?
Yes, can you hear me now?
Yes, we'll go back now to, there we go.
Thank you very much.
Go ahead.
So as I started saying, which I don't know if you heard, I'm Elena and I'm project manager of open calls in ICOS. So what we are doing in ICOS is we are trying to design, develop, and validate a MetaOS for a continuum. And we are going to do it by extending existing platforms and creating a platform with not only cloud computing resources are managed, but also edge IoT devices are integrated. Next slide, please. So this is the main architecture. As you can see, there is cloud versus the edge. There are nodes that can join, leave, and move throughout the continuum, and 3 special nodes: the agents that execute the user's workload, the controllers responsible for managing the agents, and a special one called a lighthouse to simplify and automate the dynamic onboarding of ICOS agents to ICOS controllers. Next slide, please. In this architecture, for the first open call, we are looking for 5 new use cases. So we have 4 existing pilot use cases in ICOS project already, and we're looking 5 more Deadline for the first open call is being 17th of November at 17 CET. So we are looking for consortia of technology provider and end user. The maximum amount of funding is 200,000 euros. So the activities that can be funded are listed on our webpage. You can see them there, but we are welcoming and open for all new use cases and whatever you have in mind to help us validate the ICOS architecture and incorporate it in the ICOS project in general. That is all. Thank you. And all the information can be found on icosproject.eu website that I will share in the chat.
Great. And anything further, you can meet with Elena in the breakout room session after the use case presentations. Tassius from Nefele, go ahead.
Oh, nice. Thanks also for the invitation to present our open call. My name is Anastasios Zafiropoulos, coming from the National Technical University of Athens, and we are coordinating the Nefele project. So if we move to the next slide, it's an overall information about the open call that has been very recently announced. It was the 1st of November and running till the 10th of January. We are looking for applicants coming from SME startups and mid-caps, and we're giving up to 76K per beneficiary. You can find also the link to the open call where we have the details about what is required per applicant. In a very, very short highlight, we are looking for extensions in an open source software stack that we develop in Nefele, targeted to virtualization of IoT devices and provision of services as generic functions to enrich this software stack on one hand, but on the other hand, also to develop specific types of what we call virtual objects that can undertake the role of virtual counterparts of IoT devices, but also the role of digital twins. So if we move also to the next slide, just as a very short information, the software stack consists of 3 layers. So we tackle interoperability and convergence aspects of IoT devices in the physical convergence layer. In the middle, in the backend logic layer, we have different type of IoT enablers, I would say, that can support generic functions for IoT devices and IoT data management. And in the upper part, we tackle aspects related to the convergence of the virtual objects with edge and cloud computing applications. So at the end, we offer an integrated solution applicable across the continuum. And in the right figure, we just show how this kind of virtual objects and a notion of composite virtual objects that consist of more than one virtual objects can be implemented and make interoperable with application service graphs that are also developed in the form of use case. So much more we can also show later on in the breakout session. So many thanks for this time to present the open call.
Thank you very much, Tassius. And finally, we have Ana Luisa from Nebulous to present theirs.
Hello, everyone. So Nebulous is developing the MetaOS platform. We will have 2 open calls in the future. The first open call will be open from mid-February during 2 months. And while we are still to define the challenges that we will offer to the third parties, we know that this action will be focused on the validation of the basic aspects of the platform, and we will be offering 5 projects. The funds, they are 150K. And eligible organizations will be micro, small, and medium-sized enterprises or consortium that joint research institutions and organizations of category 1 in a collaborative third-party project. Next slide, please. So focusing on the main goals of the project, as I said, we are developing this MetaOS platform that enables transition for brokerage ecosystems to seamlessly exploit edge and fog nodes with multi-cloud resources. At the moment, we have 5 use cases, one in precision agriculture, supply of fresh food to a city, windmill maintenance that we are focusing here today, the crisis management use cases, and the computer vision for city maintenance. I would like to add here that while we are still to define, as I said, the challenges to be offered for the third parties, we know that we are looking for new use cases to be exploited by the FTTP beneficiaries. We know as well that the open call, as I said, the first open call will be launched in mid-February, will last for 2 months. After that, we start the evaluation process that will be foreseen to be concluded after 1 month, and the projects will start running from mid-June 24. I'll be happy to address your questions during the after break. Thank you.
Thank you very much, Ana Luisa. And before we go into the breakout sessions now, we're going to hear from use cases. So as I said, the conversations have led us quite nicely to where we are. So we'll first hear from Fotini Satake from Cosmote, then we'll hear from Marcin from Electrum, then Rosalia from SSE Electricity, Francesco from Emotion, also with Prashant from ASM Turney, and Alejandro Arias Diaz from Odin's, and then finally Michael from TTA. So each of these use case owners is going to give you a quick 5-minute understanding of what's the use case about, and you can meet them in the breakout rooms later to go into detail either behind the tech or behind the narrative point of view. So if I can have asked Fofi from Cosmote, from the telco provider, Greek telco provider, to take over and give us a quick introduction to their use case on energy efficient, healthy, safe and sustainable smart buildings.
So hello all, I hope that you can just now see my slides.
Perfect, right? Yeah, go ahead.
Okay, thank you very much for the invitation to be here. So as Bernard said, I am a principal engineer at Cosmote in Greece, and I will be presenting to you today the use case that is developed as part of the Aeros projects to showcase how the Edge Cloud Continuum meta operating system that the project proposes help us actually deliver energy efficient, safe and sustainable smart buildings. Now, let me see. Okay, so the idea behind this use case actually came during the coronavirus years, where we have realized that the pandemic has actually disrupted the traditional working norms, as most companies had actually adopted flexible working models, rotating between in-office and remote working models, which has led to limiting the occupancy of the building rooms, while at the same time deploying more flexible, more mobile workspaces, workplaces for the employees. But putting as many people as possible in one room so that to maximize the use of shared commodities, which would be a very nice idea for energy efficiency, is not anymore acceptable due to health conditions. The idea is therefore that trying to actually balance between the social distancing, the energy consumption, the organizational procedures and policies, as well as the employees' preferences, becomes a dynamic and complex task, leaving room to the project to showcase the developments, exactly because we consider that the building notation stands very well with the far edge concepts of the project. So the use case itself is going to be really implemented in an actual building of Cosmote in Athens. And the use case, apart from Cosmote, who stands not only as the end user, but also as a technology provider, since we are participating with our basic IoT solution, is also going to be supported by UPV, NCSRD Demokritos, Focus, and the Invoices partners. Now, we are starting, as I said, by from the basic IoT end-to-end application that is delivered by Cosmote, which contains a vast majority of sensors in type, also as in numbers, which application is actually transformed as part of the project to follow the Aeros infrastructure element principles. These sensors are already started getting deployed in the building of Cosmote. They generate data that, as for all IoT systems, get collected by the IoT gateways and then transferred back to the IoT backend systems for further processing. Based on this system, we are delivering, as part of the use case, an expert system that collects these metrics from the sensors, has a view of the historical data, both on energy consumption as well as the emissions. Of course, other constraints and requirements coming from the employees' data and their preferences, so that by employing artificial intelligence to be able to determine, first of all, the root health conditions, and also applying energy efficiency criteria to be able to appropriately recommend the appropriate seating placement to an employee that is actually entering the building. At the same time, what we are trying to do is, by using the data that we have collected from the sensors in the rooms, to be able to actuate the ventilation, the heating, the air conditioning system, as well as to control the luminosity. Now, what are the challenges that we have seen in the implementation of this use case, and how does the Aeros implementation help us provide innovative solutions? First of all, we all know that in the smart buildings ecosystem, we have a big variety of sensors, types, systems, and numbers, which is very difficult to manage, considering that if we want to create a smart building ecosystem where we could have an open, adaptable, vendor-agnostic solution.
Last 30 seconds.
Okay, I don't think that I will be able to finish in 20 seconds, but okay, so we see that the complexity of the ecosystem is actually handled by the Aeros architecture layer and the abstraction layer that allows us to provide more dynamic integration of the components of the system. And then we also understand that we have a huge number of data that is generated in the building and is meaningful mainly for the building, which makes the rationalization of the autonomous decentralized decision-making at the edge. And this is a bit where the Aeros Edge Cloud Continuum directly caters for. All the components of the Aeros architecture are really contributing to energy efficiency, because what we are actually proposing is a very intelligent and efficient use of the infrastructure elements, so that to do the appropriate placement of the application components and reuse the infrastructure elements existing in the ecosystem as much as possible. Obviously, in the use case, we also generate a number of IoT automations and exploit as much as possible dynamic controls for the actuation of the energy efficiency. I just want to point to two things here, because they are very relevant to the discussion that we are going to do in the technical rooms. How could we further expand this? What is the subject that can be of interest for the Aeros Open Call? First of all, we would like to incorporate in the Aeros architecture niche communication technologies. 5G standalone IoT gateways that would allow us to onboard network application capabilities are a very good addition to the work that we are doing already. And also, in order to achieve energy efficiency, we need to have a good understanding of the energy consumption. And while we can calculate energy consumption, this is a process that it is tedious both in time and money, because we need to interfere with metering devices to all the energy consuming elements of the system. Any system, any algorithm, any idea that would help us actuate this in a better way is also a very relevant to the use case addition. I think that we can discuss.
I'm going to have to kick you off. I think if we can pick up the conversations in the breakout rooms. And thank you very much, Ruffy, for putting together the presentation and also for the collaboration. Just to say, across all these use case owners, thank you all for being the core part of building this event today. Thank you, Ruffy.
Thank you.
Great. If I could call then, also sticking with Eros, onto stage, Marty from Electrum, which is based in Poland but operates across Central Eastern Europe and supports the building of this new energy paradigm that we're seeing with partner organizations. So, Marty, over to you.
Thank you, Brendan. So yes, here at Electrum, we are developing a very complex virtual power plant solution. This is a hardware and software solution, and for it has many components, many modules, such as SCADA, the supervisory control and data acquisition software, and we gather all the data from energy infrastructure and process this data in multiple different domains. In general, goal to achieve better energy efficiency. And for this pilot with our ARIOS program, we are investigating the case to move the load, the compute load, to the edge, and also how to orchestrate the distributed data center, like containerized data centers, and orchestrate the load, the energy consumption in time of these data centers by orchestrating the flexible energy source, by knowing where the energy is the cheapest. Either it's a PV or a grid or energy storage system. We process all this information. If you can switch to the other slide, to the next slide. This is a quick diagram that shows how the system works. It can be an edge computer that you install in a small factor in existing transformator station or substation, but it can be also a large container full of servers, and we have this connection between we are gathering data from all the energy meters, and we control the energy storage system with energy scheduler, which is the machine learning driven algorithm that autonomously charges and discharges the storage. In this case, we are able to very flexibly provide the best green energy for a data center and also process a lot of local data on premises directly on this edge computer, like, for instance, a video analytics. I know the time is running out, so the next slide will show the outcome that we would like to have with this project. So basically, frugal AI, right? The increased efficiency for machine learning operations, limited carbon footprint. We would like to, just to give you an example, that there are some applications or deep learning processes that could be triggered on demand. So only, for instance, that we have some surplus energy or the cheapest energy, green energy only, we can trigger the compute load to process the deep learning, training the models. So flexible orchestration, very stable and secure runtimes for this critical energy infrastructure data is very important for us. And this economical reason and green energy share of this whole operation in this moving trend, moving from centralized data centers to more decentralized green data centers.
Thanks, Marcin. Thanks a lot. And very interesting, as you say, only run the heavy processes when the carbon is low. Excellent. Yeah. Thank you. So moving on to the next one. So we're hearing from Rosie from SSE Electricity, which is a retail energy provider and generator based in Ireland. So over to you, Rosie.
Thank you. Can I have the next slide, please? And so my name is Rosie. Thanks for the invitation. I'm very happy to participate to this event. I work in SSE Electricity, and my company is one of the partners of the ICOS project. So ICOS IoT to Cloud operating system aims at developing a meta operating system that will leverage IoT, cloud, and edge capabilities. You've heard Elaine already mentioning this, and if for more details, please join us in the breakout room later on. ICOS includes more than 20 organizations in 11 different countries in Europe. It's a 3 years project. We are just about finishing the first year of life of the project. The involvement of SSE Electricity is it's through one of the user cases that will be used to validate ICOS meta operating system. And the idea for us would be to build an energy management and decision support system using advanced and reliable machine learning techniques. So this will be tested through data collected by 5 Irish households, which are equipped with a smart technology like solar panel, EV, smart meters, batteries, and heat pumps. So ICOS, through the help of ICOS, in the user case, we will leverage cloud and edge capability to build real-time solution to shift people habits in using energy away from peak times into, like, for example, night times. And we have heard about this in the panel as well. So can I have next slide, please? So the way it will work, at the moment we are in the phase of the deployment phase that will be starting very soon. We will deploy IoT devices to monitor real-time consumption in this and exportation in these 5 houses. And the data will be sent to an edge device, which is located in the house. So we'll have 1 edge device per house. And in this device, ICOS meta operating system will live, and it will use ICOS will use and orchestrate the resources to then build artificial intelligence model for energy making decision. Then will be fed back to the customer with suggestions tailored to their specific needs. So obviously there is a business need for this, as a company like mine try to build a tailored solution for their customer and meeting their sustainability targets, but also, and obviously more than anything, will benefit the clients, because they through following this artificial intelligence decisions, they should see a decrease in their cost, but also maximize the use of renewable energy and minimize consumption for the grid. Can I have next slide, please? So this type of customer that we have here in ICOS are what we call the omnisumer. So people now are not just using energy, they're producing energy. In the future, they will exchange energy between peers to peers. But the omnisumer are not the only stakeholder for ICOS, also energy companies, as I was mentioning before, because we can target very tailored, we can build tailored customer solutions. We can provide a more detailed energy consumption reports for customer, but also by shifting the habit of people from peak time to off-peak time, this will create a more reliable grid, avoiding grid losses and increasing green energy. Again, this is a bit of a quick overview, but if you want to know more about ICOS and ICOS applied to the user cases, please join us in the breakout room. Myself, Elena, and Andres will be very happy to talk to you. Thank you.
Thank you, Rosie, and thank you for putting together all your information, and look forward to people discussing further in detail with you. Perfect. And then move on to Nemo. So we have the 2 use cases from Nemo, which are actually quite linked, but we'll start off first of all with Francesco. So Francesco from Emotion, which is a electric charging point provider. So Francesco.
Sorry, Brendan.
Prashant first from ASM Tourney. Go ahead, Prashant.
Yeah, exactly. The presentation will start with Prashant.
Okay. Hello, everyone. I'm Prashant, and I'm a junior research engineer from ASM. So ASM is participating in NEMO project primarily in the capacity of distribution system operator to validate NEMO's ability to monitor and stabilize the electricity smart grid, and also provide support to the third parties introduced through open calls. So coming to the use cases, we are working with two use cases. The first one is smart grid flexibility. The context here is NEMO will investigate advanced AI ML based analytics to identify potential local grid discrepancies and monitor power quality to provide timely alarms when the system is approaching unstable operational boundaries, which could lead to power failures. Also, this would be beneficial for balancing intermittent feed-in from renewable energy sources. So the goals of the use cases are to improve the distribution grid operation and the power quality. By enhancing distribution grid operation and power quality, the aim is to provide comprehensive insights into the network parameters for the grid operators. For example, to have the services of forecasting the generation or consumption, to have a better knowledge of the network parameters, and to be able to guide operators in their decision making, and also reducing the impact on the grid due to the voltage variations due to the reverse power flows by surplus energy produced by the intermittent renewable energy sources. So the grid functioning will be optimized and the self-consumption will be increased thanks to the reinforcement learning algorithms that enhances the performances of the grid by leveraging on the energy flexibility. Next slide, please. So the infrastructure for this use case are the phasor measurement units, which are deployed in the primary substations capable of monitoring voltage, active and reactive power, and other electrical parameters in real time, and also power quality analyzers, which measure various electrical parameters to access and monitor the quality of electrical power in a system, and also electrical IoT smart meters, which are capable of monitoring the energy consumption in real time and transmit the data. So the actors of the use case are the distribution system operator, which is us, and prosumers who produce energy using the renewable energy sources, and also renewable energy source unit. That was quick. I will pass the floor to Francesco to continue presenting the use cases. Thank you.
Thank you very much, Prashant. So I will introduce to the second use case about the Italian pilot site of the NEMO project that is related to the electric mobility involvement in the energy flexibility provision for the grid. So we are talking about, as a context of this use case, of course, about the renewable energy transition. So we are talking about the obstacle due to the fact that the renewable energies are intermittent and not programmable. So in this way, there is the need of real-time monitoring on the grid for the real-time management of the power flows, for real-time balance between the consumption and the production in the local district of the grid. So in this direction, we deployed different IoT devices, both in the grid and of course also for the electric mobility part for the use case, and in the way to allow this kind of cooperation between the distribution system operator and the electric mobility operator, like, of course, not only the charging point operator, but also the electric mobility service provider. So next slide, please. The scenario that would be investigated inside of of the use case related to the electric mobility involved is a driver-friendly scenarios for smart city mobility for a dispatchable charging based on the real-time monitored data from the grid, from the renewable energy sources, of course, also from the consumption in the grid. And there will be the usage of machine learning, artificial intelligence for developing a forecasting system for the knowledge about the power flows in the grid. And thanks to this, will be used a blockchain-based marketplace for the flexibility provision between the electric mobility to the DSO. Next slide, please. So the goal, of course, will be to improve the renewable energy sources load balancing via the electric vehicle charging. Also use we will use also cameras around the city in the way to understand also well the traffic flow, and so also the possibility to satisfy the DSO needs. And of course, we will also investigate how citizens will be involved, So the actor will be, of course, the electric vehicle user, the charging point operator, and the distribution system operator. Next slide, please. Finally, regarding the infrastructure, of course, as I said before, would be mandatory to use IoT devices for the purpose of this use case. So we will have smart meters on the grid side, both for the consumption and production devices. And the electric vehicles deployed for the demonstration activities related to the NEMO project will be equipped with an onboard diagnostic device to collect directly the information from the diagnostic interface of the electric vehicles, and to enable to push those data, mainly state of charge, that is the data related to the potential flexibility provision of the electric vehicles to the grid, and will be used an MQTT protocol for real-time sharing with the technical partners, mainly involved for the training of the machine learning training. Yes, of course, also charging stations are equipped for this purpose with single board computers to enable both real-time monitoring and also, very important, the remote management in the way to remotely modulate the power output in real time according with the real-time production, real-time consumption in the grid. So to have a net balance in the grid. So that's all.
Thank you, Francesco. And thank you, Francesca. And thank you for Prashant for both of those. And you can meet them later to talk in more detail, and also meet with Demetrius to talk about the open calls. Thank you both very much. And then we move on to Nefele. So we have Alejandro Arias Diaz, who's joining from Odin's, which is a research and development center, and they are presenting their case, which is looking similar to Eros with FOFI, looking at the built environment. So over to you, Alejandro.
Hello, everyone. I'm Alejandro, and I'm going to present this energy management use case. Well, first of all, this is a use case from Nefele. That is a research and innovation action project funded by the Horizon Europe program. And this project aims to introduce two core innovations, the IoT and edge computing software stack, and also the as-energetic meta-orchestration framework for managing the coordination between cloud and edge computing and orchestration platform. So regarding the use case, the physical increase of cities and their population and the continuous advancement of technology motivate the need and the increasing popularity of the concept of smart buildings, emphasizing sustainability and carbon emissions reduction. Designing and operating buildings with minimal energy consumption has become paramount. The energy efficiency is a critical component of smart urban environments, further enhanced by integrating cutting-edge technologies like IoT, machine learning, and edge computing. Well, this is where use case number 3, energy management in smart buildings comes to play. This use case is led by Odins and is supported by Siemens and IBM. Well, this use case focuses on energy management in smart buildings and cities. It leverages IoT, edge computing, and cloud technology to meet a strict service level agreement requirements. By automating real-time data collection from various IoT devices, it bypasses central monitoring bottlenecks. The use case explores technical challenge and benefits. For the efficient control and customized service for energy efficiency, well-being and security using the BO stack. So Nefele also adds secure access, distribute data sharing, and advanced applications like people object detection. So in resume, the main objectives of this use case are to develop applications to allow energy efficient control actions of building equipment, to offer customized service to end users to improve energy efficiency and well-being. Finally, to provide an automation scheme based on real-time information from different IoT devices and edge nodes. Next slide, please. Okay. So this is the test bed. So the testing and demonstration of this use case will be performed first in simulation and later in a field trial scenario. This is expected to happen in a platform for IoT smart cities and buildings provided by Odins. So, well, as you can see, bottom left image, the goal is to deploy IoT devices in different rooms. These IoT devices are mostly sensors for temperature, humidity, light, air quality, but also we have other IoT devices like cameras for object person detection. So these IoT devices will be constantly measuring and sending data to the virtual objects. So now the virtual objects, these are part of the edge computing. They could be placed near the IoT devices, as you can see in the bottom right image, that in this case the virtual object is located on the roof of the building. So yeah, virtual objects have more computational capacity than IoT devices, so they will perform intelligent energy saving actions, not only based on the sensor measures collected by the IoT devices, but also the information and data coming from other nodes. This will drive efficient use of renewable energy sources and the reduction of peaks in the energy consumption. With this interaction, we are implementing the IoT to edge to cloud compute continuum. So these virtual objects are also connected to applications in the cloud for managing by administrators or AI. So next slide, please. Finally, in this slide, I'm going to talk about the stakeholders and the expected outcomes for each stakeholder. So we have the citizens. The citizens drive building and city usage, influence the choice of solutions in their lives. So their priority include real-time monitoring, AI driving data analysis, and enhanced security for cost reduction, increased efficiency, and user-friendly tools. And the expected outcomes for the cities are the cost reduction thanks to the energy management, a dashboard for monitoring and managing the applications, and the authentication and authorization management tools. Then we have the local governments, strive for efficient citizens service through resource optimized solutions. They prioritize real-time energy monitoring, AI supported decision makings, and stringent privacy measures. So the expected outcomes for the local governments are distribution of smart energy management applications, secure group communication for constrained devices, and also authentication authorization management tools. And then building managers and energy communities. This aim to enhance utilization through advanced monitoring system. They prioritize user information security, real-time monitoring and data analysis and AI-driven decision-making for an intuitive and accessible management interface. Well, the expected outcomes are the smart energy management and dashboard also for managing the application. So finally, we have the security companies that can optimize access control and allocating tasks with security devices and cameras. To ensure efficiency and privacy, the security must offer distributed image processing, real-time data access, and advanced object detection tools. The expected outcomes for this stakeholder are the improved object detection tools and the control dashboard.
Great. Thank you very much, Alejandro. And moving finally on from managing the consumption onto fixing some of the challenges around generation. So if I can then invite Michael from TTA to give us an overview of how they're applying the nebulous architecture to windmill maintenance and wear and tear. So over to you, Michael.
Thank you, Brendan. So hello, everyone. My name is Michał Kusiński, and I'm working with TTA on windmill maintenance use case in the Nebulous project. So we are basically using Nebulous to optimize our edge and cloud processing. But before I go into the details on that, I will try to explain a bit what the use case is all about. So what we are actually doing, well, we are analyzing the images of the wind turbines to look for some damages on them. So when the windmill is used in the field, it's exposed to some environmental it's affected by the weather, basically. Like water, wind, some flying objects, birds, lightning strikes. There's a number of things that can happen to the blade. And since they are supposed to operate for a long time, we need to maintain them, fix those small damages to avoid becoming big damages. So that's what we do. And there's plenty of damage types that can happen to the blade. And I won't go into details of that, but there are like 20 or 30 types, depends how you actually classify them. We also assign some severities to those damages. So we try to understand how bad is it, how quickly we need to fix it. There's like normally 5 grades, so from severity 1 to 5. And this inspection and the focus on the inspection depends a lot on the environment that the blade is on. So it might be a desert, it might be an offshore turbine somewhere deep in the sea. So those two extreme opposites are quite different in terms of analysis and maintenance. So what the process is about, well, it's first of all, we need to collect the data. Normally, nowadays, it's done mostly by using the drones. Then that data needs to be processed somehow. It used to be done by humans. I mean, it's still done by humans, but now they have a help of some machine learning algorithms for that. And finally, there's a report that goes to the maintenance team to see what needs to be fixed, what not. The challenge is amount of data, well, there are 2 aspects of that. I mean, maybe in terms of machine learning processing, the amounts of data are not that huge. One turbine is a few gigabytes of data, but for human, analyzing few hundreds of images of a single turbine is pretty mundane process and quite error prone. So that's why the software and the machine learning. Can I have next slide, please? So what's for us, like TTA, cooperation with that Nebulous project is a transition from mostly cloud-based batch processing to more edge cloud real-time kind of processing. So we used to collect all the data, I mean, not us as a company, but some maintenance crew was doing taking the pictures, downloading them, uploading them to the cloud, so we can process them, and then human could process that further. So now it's changing. We have the software running on the drone. We can do some quality assessment, blade part detection. It might be useful. I mean, it's used in many ways, but one of the aspects important for the UAV operation might be a loop closure, so understanding or confirming that the location I am right now is the location I expect it to be. It's for the autonomous flight mode. But there are also some other places where we like to know what part of the blade we're actually looking at. So those are things that are running right now in our software pipeline, data pipeline. That's what we are doing on board the drone. Then we have an edge component, so it can be laptop, it can be an actual edge server nearby the wind farm, where we do the first assessment of what we collected. So we look at the damage detection, meaning we are finding some bounding boxes where damages can be located. It's a clearinghouse at the same time, because we for the clean blades, we can say, okay, this is nice for bookkeeping, but we won't be processing that image further. And finally, we are preparing some crops to downstream processing. And at the end, damage classification severity assessment. So the edge and cloud part is something that Nebulous is actually providing us tools for, to migrate some components between the edge and the cloud, depending on the load that can happen. There are some use cases where we, for example, lose connectivity and there is some batch of images to be processed instead of constant flow like normally from the drone. There might be multiple drones in operations that are actually affecting our edge and cloud nodes, and that's where Nebulous is actually doing its work by changing the infrastructure as it works and also optimizing it cost-wise and processing-wise. Can I have the final slide? Thank you. And why we do it? Well, first of all, windmill maintenance is something that we started company with and working with a few companies before, mainly wind farm operators or some inspection companies that actually do the drone flying. It's the primary application of our software. However, there are some other applications we're looking at. The most obvious one is solar plants, where also drones are used for inspection. And the same technique, that same kind of pipelines can be reused. There's electricity grids, both lines and pylons require some regular inspections, and we can transfer fairly easy some of the ideas to that verticals. And finally, some types of pipelines, we worked with one of the companies who is actually maintaining the oil pipelines, and that's also a place where this type of processing makes sense. Thank you.
Thank you very much, everyone, and thank you to everyone who's put in the effort there to describe their use cases. And now comes the time to meet and to talk to each other. Just to say thank you all very, very much for participating today. We hope you've had a good time, and specifically like to thank all the partners from the projects, both the use case owners who've put a lot of time into shaping how they can talk with you, and also for being very generous and open in participating today, and to the open calls coordinators as well, who've helped in driving this forward. So just to say thank you all very much again. Where you can find us next is in Paris, in UNlit, which is the next energy event that's happening. If any of you are there, please do come over. And the next opportunity as well, apart from the open calls, is for the large scale pilots, which is having its info day and brokerage session happening in December on the 4th, both online and in person in Brussels. And to say we will be asking all the presenters today if we can share their slides, and you will then be able to find them on the website where the recording of the main room will be held as well. And to say thank you very much to our colleagues from Trust IT, to Diego and Maria, who've really helped in bringing this event together, and also finally to the team here in BlueSpec. So to say thank you very much to Elizabeth, who's worked very, very hard in making sure that this happened, to the Commission, to Rolf and Jan, who've been working closely with us, and finally to your colleague Isis, who's been working there. So thank you all very much, and we hope you have a lovely weekend, and hope that you managed to have a good, enriching conversation, and look forward to continuing our collaborations. Thank you all.